Hi guys, welcome to another video on my YouTube channel, and in this video we are going to cover prompting techniques. In our last videos, if we have covered prompting templates, right? So template is basically a structure which you can reuse to write different prompts, where you provide different variables and you can use the variables to change your prompt at the runtime and expect a response from the model. Techniques is different in a way where you provide how you will get the answer, whether you want your model to give you a reasoning, or you want your model to give you an explanation, or you provide some things to the model so that it can perform better for your query. It is a way to write different prompt. There are different techniques that you can use to write a prompt so that your answer is more creative or maybe more reliable, or it gives you its reasoning as well, so that you can rely on the answer. So let us start with our first prompting technique, which is zero shot prompting. Zero shot prompting is the simplest technique where you provide an instruction to the LLM model. The instruction could be a single sentence, or a bulleted sentence, or a paragraph. Anything that you provide to a model along with the role or whatever criteria we have covered for a prompt in our previous video, if you follow that, or if you do not follow that, anything that you provide to a model which contains a simple instruction in a paragraph form or in a bulleted points or any form is coming under zero shot prompting. So for example, in this example, if you want to learn about some binary search, right? So you can easily say explain binary search for beginners, or you can provide a role something like this: you are an instructor and explain binary search for beginners and keep it under 200 words, something like that. Where you are providing an instruction in simple language is coming under zero shot prompting. Here you are not providing anything else, you are just providing your context. You are asking model to provide you some answer based on your instructions, and that's all. Here model is completely relying on its previous training. So while building a LLM model, training has been done, right, along with lots of data. So model is only relying on that training. It takes your query, it divides it into different tokens, it vectorizes them, passes through a transformer and all those things. Then it gives you answer based on the training it has already gone through. So it only looks into your prompt and gets the clarity of the instructions, what it needs to do, and according to its previous training, based on the context it takes from your prompt, it provides you the answer. There is no explanation shown for this kind of prompt, right? It will just start giving you binary search definitions and maybe some examples and all. So let's try this prompt on ChatGPT. I'll just put this small prompt on ChatGPT. See, here it is just providing you the definitions about binary search along with one example as you have instructed in your prompt. It is using a simple language with numbered points, and it is providing one example and a use case of a binary search. So all it is coming from its previous training. It has nothing to do with your prompt. Now internally, as I have already told, model reads the instructions. It activates general knowledge patterns from its previous training. It guesses this looks like an explanation task and audience is beginners from your prompt. Then it starts generating token based on common explanation styles that it has followed for everyone. There is no tone set or nothing defined in your prompt. If you will set a tone, it will just take that tone. Otherwise, it will just jump on the common tone, which is by default set for it because of its previous training. The pros of a zero shot prompting are it is very fast. As you can see, it gives you the answer immediately, almost immediately. Prompts will be short because you just have to provide your context. If your context is short and if you are providing simple instructions, prompts will be very short. So cost will be less. It is good for common tasks like learning or explaining about a topic, summarizing a doc. For these types of tasks, it's a very good prompting technique. There is no need of any kind of data you need to provide in your prompt. Cons are output may be inconsistent. So for example, I have provided this prompt right here with binary search. It is giving me a bulleted points in the numbered format, then it's giving me an example of 2, 4, 6, 8, 10, 12. Let's say if I provide this prompt again, let's try it here only. See, output is a bit different from the previous one. So as you can see, example and the way it is defining the binary search as well as this thing is bit different from the previous answer. So every time, even if you provide the same prompt, output may differ a bit, or it may differ by a lot based on your complexity of your prompt. So tone, style and everything may vary, and it can misread vague prompt. So if your prompt is not very clear, it has some vague instructions, then it can confuse the model and you might not receive the answer that you are expecting from it. So in this case, there is a con. So obviously you have less control on your on the answer because you are providing simple instructions here. So there is no control on the tone or the structure of the answer that we will be getting from LLM. So there is less control for that. So the next prompting technique that we are going to learn about is one-shot prompting. One-shot prompting is just the advancement of zero-shot prompting, where you provide everything that you provide in zero-shot prompting along with an example. So for example, if you let's say you want to LLM model to explain about this stack topic, then you say something like this. So you are providing an example, like if the topic is stack, explanation is something like stack is a linear data structure that follows and so on. Then examples, it stacked on top of each other. You are providing an example to the model and then you are asking your query, now do the same for topic Q. So here what model will see, it will just take the example into the picture along with its previous training. It will get the tone and something like this from your example. It will set the tone, it will get the output structure, it will get how to provide you the answer. Then it will go to your query and it will use the same format, tone or structure that it has extracted from your example and provide you the output in the same manner. So let me try this prompt on the LLM. So this is not an actual example because I haven't provided any definition. So let's keep the dots and let's pass it. See, it has given you the example in the similar format, right? So here you have provided an example of topic stack. You have provided an explanation, then an example. It has followed the exact same structure. It is providing you explanation along with some images, then it is providing you an example, nothing else. And as you have seen in your example, you have just provided some theory. You are not explaining it by numbers or by array or something, but in the previous example it was giving an array, right? Here it's not giving you an array or something like that. It has only provided you some sentences in the example. So it has provided the example of a ticket counter instead of giving you an array or something like this. But if I do just explain topic Q, let's see the difference. See, the answer differs by a lot. Oh, from my topic it's taking top subtopic. Anyway, the answer differs by a lot, right? So here because of your example, it understood that the queue you are talking about is a data structure queue, and the way it has to give answer is this format, where it has to provide explanation in 1 or 2 lines, then example in 1 or 2 lines without providing any array or something like that. So internally in one-shot prompting, when you provide an example to LLM based on the scenario, what model reads that example, it finds out the pattern from that example, like tone, structure, length of the explanation, and then when it provides you the actual answer for your topic, it will say based on the previous training as well as from the example, it will provide you the explanation following the same structure, tone and length. So this just continues the pattern. So it takes out the pattern from your example and continues the pattern for the next topic. For defining the tone, structure and length, it will not look into its previous training. It will just totally be based on your example. So the pros here are better consistency. So here you can define how you want the output from your model, and expectations are clear. Like you can now expect from the model that it will give an explanation and the example, and whatever you have provided, it will just provide the answer in the same format. It's still simple because you are providing just example, and it's great for creating something. Like if you want to create a blog or something like that, you can just provide an example like create a blog like this on this particular topic. Then model will go to that blog if the URL is public. It will read the structure, tone, format, how the explanation is needs to be done, and it will use the same pattern to provide you the answer for your new blog. Cons are limited control. Again, you are just providing tone, structure, and length. So a little bit of more control than the zero shot prompting, but still limited. Then one example may bias too much and not ideal for complex tasks. Obviously, because you are providing only a single example, right? So for the task like explaining a stack and explaining a queue, this is good enough because these are very common topics and very beginner level topics if you are learning about DSA. So these kinds of techniques are good enough for simple tasks. But the problem is when you move to a complex task like design pattern, system design, and all those things, one example may be biased. So it may just look into the example, and it may assume that every explanation needs to be in the same format, but it may not work for complex problems. One example can create a bias for the model. Hence, we are moving to few shot prompting. Few shot prompting is again an advancement of one shot prompting, where instead of one example, you provide multiple examples. So up till now, we have seen three prompting techniques, right? So each of them is a slight advancement of another. In short, if you provide no example, then it becomes a one-shot prompting. If you provide one example only, it becomes one-shot prompting. And if you provide multiple examples, it becomes a few-shot prompting. So here also, model behaves in the same manner internally. It will go to your all the examples. It will look into the structure, tone, and the length of the examples you have given, the pattern it needs to follow to provide the answer, and then it will follow the same pattern to provide you the explanation of your new topic, which is DQ in this case. So pros and cons are similar again. In pros, high consistency because more examples will make the model more clear. Strong style control because we are providing more examples, right? So there is very less chance of getting an example bias, and it will just get more clear on the tone, structure, and the format it needs to use to provide you the answer. And it's best for accuracy because with multiple examples, a model is clear. It will not get confused, and it will give you the accurate answers. So cons are long prompts because the more examples you provide, more lengthy the prompt will become, and more token cost you have to bear. Slow responses and overlifting risk. Responses may be slow. So as the prompt becomes large, the response may be slow, right? If your examples are huge, you are expecting a big response from the LLM, then you have to provide those kinds of responses in your example as well, right? So prompts will become very lengthy, and model might take time to parse those examples and figure out the different structures, and it may provide you responses a bit slowly. Overfit may happen. So let's say like a model training, like if you have worked on a neural network training, overfit happens there, right? So a model keeps on learning on the trained data, but it doesn't perform well on the test data. So things like that can happen here as well. So it may overfit from your examples, and it may not perform well for your test data or maybe for the new topic. So this is a slight risk here, but it is very rare because right now all the LLM models that are out there, they are highly trained on the previous data. So if you are providing these kinds of example, at least for the simple task or maybe basic coding questions and system designs and all, it might not overfit because it's also getting trained on lots of data provided by the other users as well, right? But there are still chances, if you are providing many examples, then it gives priority to the examples that you have given to find out the format, tone, structure and everything, and it might overfit in that case. So next is chain of thought prompting. So in all the prompting techniques that we have seen so far, we are seeing that model is providing you just the answer. So as you can see here, when I ask the LLM model to explain me about the topic Q, it's giving me the explanation about the topic Q, and it is providing the example based on my the previous example. And here as well, it is just providing me the answer directly without any process that is being followed by the model and without any explanation about it. So to go through that, we have other types of prompting techniques. The first one is chain of thought prompting. So chain of thought prompting technique is a technique when you explicitly ask a LLM model to reason it step by step before giving the final answer. So here you tell the model that instead of giving straightforward answer to the user, think about it step by step, and you ask the model to explain those steps so that it becomes more clear to you as well how the model reaches to the answer. Here the model, it divides the complex problem into the smaller steps, and on each steps it provides you the explanation, and it reduces the logical errors, because instead of directly giving you the answer for a big complex task, it divides the task into small tasks. It goes through all those tasks step by step, provides you explanation on every step, and it will then give you the final answer. So there is a less chance of logical errors here. So the outputs are more reliable and explainable because model will give you the whole explanation how it reaches to the answer. A prompt will look something like this: solve this particular problem step by step, explain your reasoning clearly, and then provide the final answer. So these three lines are the key reason for the chain of thought prompting. So here you explicitly ask the model to divide the problem into different tasks and solve each of them step by step, and also ask the model to explain its reasoning so that you know how it went through the process and how it reaches to that answer. So let's try this with this particular example. So there is a small prompt. Let's try this in a new window. I'll just refresh it, and I'll just provide this. I'll just provide this simple prompt. It's a zero-shot prompting, right? Let's see the answer. So it is providing you something like this: short answer, learn what gives you leverage, not hype. So it's providing me Node.js, Java. Basically, it is providing me different types of languages with the pros and cons, I think. Yeah, something like that. And it is giving a blunt recordation, primary, secondary, and optional power, and all those things. But if I use this kind of prompting, let's see the difference in answer. So here you have provided a basic context as well, that you want a job in 6 months and you already know a basic JavaScript. Then you are asking the model to compare different options step by step and recommend the best choice. So here as you can see, it is just providing you different languages and pros and cons, why you should learn it and you should learn it, and it's providing you the recommendations in the end. That is here: primary Node.js, secondary Java, optional power, move, go. So in this kind of prompting technique, so it is evaluating based on the context that you have basic JavaScript knowledge, no deep backend framework. So it is assuming that you have not learned any deep backend framework because you have not provided anything like this in your prompt, right? So it has assumed that you are not aware of any backend framework, and your goal is to get a job in 6 months. So it is based on this context. It is advising you to not reset on a new language and learning JavaScript in detail. So it may be in the end asking you to learn about TypeScript and Node.js only. Let me straight move to the recommendation. Yeah, so in the final recommendation, it is asking you to choose Node.js plus TypeScript. It's not advising you to learn about more about JavaScript. It's asking you to combine the Node.js and TypeScript because you already know a bit of JavaScript, right? So as you can see, it is also comparing different languages for you because you have asked the model to explain it step by step, right? So these are all steps it has evaluated based on your based on the context in your prompt. So step one, it is evaluating what you know already and what you should not do. So in the first step one, it's telling you to not start on a new language and do something on JavaScript only. Then comparing backend options against job focus criteria. So it is telling you what criteria it is using to compare different options, which you will not get in your first prompt, right? It will just give you the straight answer that this is good for what and this is good for what, but it will not tell you the criteria in your first prompting, right? But in this, it is telling you all the criteria that it has assumed in providing you a suggestion. So learning speed, job demand, interview friendliness, project ecosystem, risk in 6 months, all these criteria it has used to compare different options for you and provide you a final recommendation. So now it started comparing different languages. Option A, Node.js, learning curve, job market, and interviews, and everything it is providing to you for Node.js. Then it is comparing for Java plus Spring Boot, same thing. Then Python with Django and Fast API, same structure you are getting for this as well. Then Go language it is comparing, and you get a final comparison table at the end as well. And then the final recommendation for you is Node.js plus TypeScript. And it is also telling you why this is the best choice for you. Okay, so now again it is also giving you an exact stack that you should commit to, which is JavaScript, TypeScript, Node.js, Express, Postgres, Redis, basically the other uh, core uh, core concept that you need to deploy your applications, and you should know when you if you are a backend developer, right? So it has given you a very good answer, I would say. So this is the difference of chain of thought prompting. In a basic prompting technique, the model will just directly give you an answer, a recommendation, or a explanation on a topic. But in chain of thought prompting technique, it will explain you its reasoning as well. It will tell you what assumptions it is making. It will tell you how it is comparing different things, what criteria it is using to compare different things, and then it will give you the final answer in the end. So here you can know how the model is thinking. You can it's like asking a human to explain about something. Here you will know how the model is thinking, how the model is reasoning on an answer, and why you should follow the recommendation. Okay, so there is another explanation. This is a mathematical problem. Let's try this one as well. So let me again open a new window. Okay, I have just provided a simple prompt with a mathematical problem, and it's straightly giving me an answer that 100 minus 70 30. Now if I do it by chain of thought prompting technique, you will see it will just explain you this mathematics step by step. Okay, so now it is providing you all the context, that cost of the pen is 10, number of pens bought this, total cost this, money paid this, and all those things. The way you may be writing answers in your childhood, right? In your mathematical exams, it's providing you the answer in the same format. So this is the difference between a simple prompt and a chain of thought prompt. Now why you should use this kind of prompting technique? When the problems involve logic or calculations like these, or decision requires trade-off, that you want to know which one is better from what and why. For example, in design pattern problems and in choosing a data structure for a problem, there could be multiple data structures, right, that can solve a problem. If you want to choose one, which one you should choose, things like that, where you want a trade-off. You want learning as well, not just answers. You do not just want to rely on the answer, you want to know how to reach to that answer. For example, in this mathematical problem, right, although it's a very simple problem, so in this two sentence it's giving you this exact same thing, but here it is more explainable step by step. So basically you are learning how to reach to the answer, not just the answer. Creating educational content or notes, obviously this kind of technique is good for creating educational content and preparing YouTube scripts and tutorials. Avoid it for simple factual questions and very short creative tasks. Things like this, because as you can see in this type of task, this is a very simple mathematical problem, right? So there is not much difference in this explanation and in this explanation apart from the way of writing. So here also it's saying the same thing. Cost of 7 pence is something like this. Cost of pen per cost is this. Amount given is this, and all. Here also same thing, just different choice of words and more lengthy explanation. So for simple factuals and for factual questions or simple tasks, this will not provide you any better result. But for the tasks like for the trade of tasks like the choosing of a technology, system design, and data structure comparisons and all those things, this type of prompting will be good enough. Here better accuracy is there on complex problems because it again breaks down a problem into smaller parts, and it avoids jumping to the wrong conclusions because it will give you the reasoning, right? So if it is going wrong anywhere, you will know that this reason is incorrect for this context, and then you can just improve your prompt to write that do not assume this. Then it will you can actually improve your prompt and get a better answer. It also reduces hallucinations because it explains you the logic, right? So while explaining the logic, if it finds something that this may not reason with your problem, then it may not go into that direction, right? So this kind of prompting techniques reduces hallucinations as well. It cross checks its own assumption internally, and it is great for learning and skill building. The cons of chain of thought prompting is long responses and slow response time. So here I'm using very simple prompts, and as you can see for a simple prompt like this as well, for that technology prompt, I think I have refreshed it, right? This one. So for this small prompt as well, you have gotten a very long answer, right? Now imagine if your problem is complex, like system designs or anything else, then you will get a huge answers. So response may take some time because model needs to think about the logical steps, and it can be overkill for simple questions like this mathematical problem. It can also appear unconfident when going wrong. So chain of thought prompting does not guarantee you a correct answer. Even if it is explaining step by step, it may be possible that for a particular problem the answer may not be correct. So for that humor intervention is needed. So step by step or any prompt cannot guarantee you the correctness. So this is the con of chain of thought prompting. Now a bit more advanced technique of chain of thought is tree of thought prompting. Tree of thought prompting is an advanced prompting technique where AI is asked to explain multiple possible reasoning paths, evaluate each path, and choose the best solution instead of committing to the first idea. So here, like in chain of thought prompting, we have asked our LLM model to provide the explanation on each step, right? But a problem may have different solutions. For example, a data structure problem, a coding problem, can be solved using different data structures. It can be solved using array. It can be solved using a linked list, or maybe something else as well, right? So here we ask our LLM model to explore the multiple possible solutions, then evaluate each possible solution, basically get a trade-off between them, and choose the best path to take. Here in the chain of thought prompting, you are just asking a model to provide you an answer and follow a single path. Like let's say you want to solve a problem using some design patterns, right? Then you will just ask the model, use design pattern to this and explain your reasoning step by step. So it may pick up one or two design patterns like factory pattern and observer pattern, and maybe you use them in your solution, and it may provide you the reasoning why this pattern is good, why this pattern is not good, and all those things. But in tree of thought prompting, if you will use the same prompt in this way, it will provide you different solutions. Maybe in one solution it will use the observer pattern, in another solution it may use factory pattern, in third solution it will use maybe some other pattern or a combination of patterns. And for each solution it will provide you its reasoning, that this is good in this case, this is good in this case, this is better than that, and all. And based on the trade-off it will give you the final answer, which will be the most optimized according to it in all the possible solutions. So think of it like a decision tree, not a straight line of reasoning. The basic structure of a tree of thought prompting is: generate multiple possible approaches, explore each approach step by step, evaluate pros and cons of each step, and select the best solution and explain why. So here you provide clear instructions to the model to look into multiple possible solutions, compare all the possible solutions with pros and cons of each other, and after that select the best one which may be suitable for a particular problem. Let's jump into the examples. uh, I'll use the same problem that I have used above for this kind of prompting, again to choose a programming language and to learn. Let's try this on the here on the ChatGPT. So this is a simple. Here the response is kind of similar than that the chain of thought prompting, because it's just choosing a language, right? Here it is not a process a model needs to follow to reach to a solution, like in like solving a coding problem or solving uh, designing a system, something like that, right? There can be different paths to build a system, right? But choosing a language is like a 50-50 task, right? A simple task. So it is just basically choosing different languages like Python, JavaScript, and Golang. It is comparing all of them based on the learning curve, job demand, future growth, and all. And after comparing these three, it's providing you a answer. It's comparing job demand, future growth, and then the recommendation. So it's recommending Python now. So in the earlier prompt, it was recommending you Node.js because you have provided a context where you said you knew a bit of JavaScript. So now it is recommending you Python on a generic basis. So in case of a more complex problem like designing a scalable payment system, let's see. I'm not sure how this prompt will behave, because for this type of problem, this prompt is very small with very less context. But let's try. Okay, this is just a different response I sometimes get from the LLM model. When LLM model provides you more responses, more than one responses, then it looks something like this. Let's look into the response one. So here architecture approaches, I think one is monolithic payment core plus external integrations, something like client goes to API gateway, then payment monolithic, then goes to DB and payment gateway. Then there is step-by-step analysis of scalability, weak for larger scale, its low fault isolation, reliability, complexity, and all. Then it is looking into another architecture, which is microservice based architecture, where you create different microservices for each task, like auth service for authentication, payment orchestrator for orchestrating all types of payments, ledger service, wallet service, risk fraud service to find out risk fraud, and notification service, right? These are like basic services that you need for this kind of gateway, right? So this is another approach it is looking into, and it is providing you the scalability high in this case, reliability is also high in this case, but complexity is also high in this case. Then it is looking into third approach of event driven, like PubSub, Kafka, and all, where you have microservices but there is a PubSub in between, which different microservice may use to talk to each other, basically provide the events. So scalability and reliability is again high. Design complexity will again high because you are adding PubSub event messaging to it, so basically async task. And then again another approach it is comparing about is Saga based distributed transaction architecture. So again, it is comparing the scalability, reliability, complexity, and then a final table with all of them. So best architecture choice, it is giving you hybrid event driven microservice architecture. I think it didn't recommend any of them straightforward. So this is event driven architecture and microservice architecture. There is Saga architecture, but the recommendation here is uh, it's some hybrid choice where it is combining, I think, event driven architecture and microservice architecture. So it is combining both of them and providing you a answer. So here, as you can see in all the previous types of techniques, it was just going through a solution and it was providing a recommendation based on that. But here it went to different solutions, different ways this problem can be solved. It compared all the solution based on the scalability, reliability, complexity. Then it, instead of recommending any one of them like as it is combining two different solutions where it is combining microservice and pub-sub architecture and providing you the answer based on that. So this is how the tree of thought prompting works. It will basically move into multiple directions at the same time, compare all the paths and provide you the best possible path that can be created from that. So this is another type of response I'm getting from model. Let's look into this as well. Here again, it's doing the same thing, only the way the response is coming is a bit different. It's providing all different types of techniques on the top. Here it's explaining them one by one, then providing you the recommendation. Now it's doing the same thing again, explaining all four of them one by one and comparing based on scalability, reliability, and complexity. And the same thing. Let's see the recommendation here as well. Here the recommendation is microservice plus ledger centric core. Okay, here the recommendation is a bit different. So as you can see, even with the same prompt, answer may differ. So here for the same prompt, the recommendation was microservice plus Sarga orchid. Uh, Final recommendation. Okay. So best architecture choice is hybrid event driven microservice architecture. Here, what is best architecture choice? Here, recommended architecture is microservice for ledger centric core. So the recommendation is a bit different in both the answers, but it explains you for each solution what how it reasoned with every step, how one solution is better than another, and based on that, it provides you the final answer. So this is how the tree of thought prompting works. Now, why you should choose this kind of prompting technique? So you should use it uh, when decision involves trade-offs like designing system, coding problems, and all. And there is no single obvious answer, right? Because designing a scalable system, there is no single answer for that. Based on the complexity, traffic, and all those scenarios, you can use different architecture to design a system, right? So there is obviously not a single answer. Where you want comparison and not guessing, like designing system production strategies and teaching how to think, not just answer. So here it will model will give you how it is thinking into different directions. It will not just give you the answer, it will tell you how it is thinking into a solution. Obviously it's not good for questions like factual task like capital of India and all. Speed is more important than depth. Here speed might be slow because it will provide you multiple solutions instead of providing you one. It will give you multiple solutions along with the reasoning of each solution, right? So speed may be a little bit less, and you need very short outputs. Obviously outputs will be here long. It's perfect for problems like system design, career guidance, case studies, YouTube educational scripts. Now, pros here explores multiple options because generates several possible scenarios and compares all of them. It kind of mimics a human brainstorming thing, like once how a human brainstorm about one thing. Once they go into a solution, think about its pros and cons, then go to another and do the same thing, right? It mimics something like that only. The decision quality is better than the previous prompts and it's highly explainable. So it will provide, it is trying to be as explainable as it can, right? Why the options are getting rejected, evaluates the trade-offs and all those things. And then it reduces single path bias. So it will not just follow a single path, it will follow multiple paths. As you saw in the previous example, it gave two different recommendations and two different answers, right? So there is not a single path it may follow. It may provide you different path based on the trade-offs that it is comparing. It explores different alternatives, and it has strong reasoning while selecting an answer. Cons, obviously token heavy and slow response time because your answers and prompts may be huge. So I have provided a very small prompt, right? But usually the prompts will not be this small, so it will be, and answers are also large. So it's token heavy and slow response time. It is a overkill for simple problems and not a guarantee of correctness. So as you saw here, it is providing you two different answers, right? So but you will be using one of them only, so you might not go with the recommendation that it is giving. So again, still not a guarantee of correctness because answer may not match what you are looking into or may be actually wrong. Okay, this is it for this video. I will be covering 5 to 6 more different types of techniques in the next video, and I'll also provide you some reading material in the description. So please look forward to it and like, share, and subscribe my channel. Thank you.